Yeah. So, yeah, welcome to the sustainability panel. Thank you, David, for the kind words. Yeah, as David mentioned before, the topic today is AI-driven sustainability, detecting wildfires for a resilient future. And I would like to start with a quote from a very well-known author, Yuval Harari. Some of you may know him. He's mentioning 3 enemies we have in the 21st century: nuclear war, climate change, and technological disruptions. We would like to focus on climate change today. And I also brought some newspaper articles. Yeah, some of you may already know the headlines. They are about the Canadian wildfires, which are occurring right now. And they are not only affecting Canada, they are also affecting Europe as well, especially with smoke, which is reaching us. So this should make us aware that wildfires are not a local problem, it's a global problem. And the second newspaper article I brought today is about the situation in Europe. So the last year was the second worst year in the history of Europe. It was so bad that the area of Montenegro burned down. So yeah, it's time to act now and not to wait. And the third article is about CO2 emissions. So here's also a record in Canadian history in the first 6 months of 2023. So yeah, enough with the bad news. What we can do with AI for sustainability-related problems. So yeah, AI alone cannot solve all problems and cannot stop the climate change, but it can help to reduce the consequences for humanity, can help to reduce carbon CO2 emissions, and can help to generate a sustainable growth. I will go into detail to our use case we implemented at Deloitte. Yeah, the use case is about predicting wildfires, and I will go into detail now. So yeah, as I mentioned before, global warming, growing population, and as well expanding tourism leads to increased likelihood of serious wildfires. And I brought some statistics how the situation is in South Africa, because this is the area we implemented the use case for. So there is 116 kilohectare of tree cover loss in the years between 2001 and 2021, as well as 3.42 megatons of CO2 emissions per year. And yeah, the first one, the tree cover loss, is equal to 116,000 soccer fields, and the second is equal to 57,000, or the emission of 57,000 cars during the whole lifetime. So very impressive statistics from my point of view. And yeah, what is our mission? Our mission is to prevent wildfire outbreaks, as well lower the effects of already occurred wildfires. So as you can imagine, it's not the easiest problem to handle. So we split our use case into 3 sub-use cases: outbreak, spread, and response. The first one is about detecting or predicting when a wildfire will occur in the next 7 days, or what is the likelihood of the outbreak of a wildfire. The second is the spread, so what is the propagation of a wildfire, which path a wildfire will have in the next 7 days. And the third task is about response, so what is the impact of intervention measures from firefighters. So as I mentioned before, it's not the easiest to handle problems, so I will mention some challenges we faced during our implementation phase. I will mention them because I think it's not just relevant for our use case, it can also be relevant for other sustainability-related use cases. And I took 4 challenges we faced. First of all is limited data availability. So especially for countries like South Africa, there is no geostationary satellite, and you can imagine for areas like California, it's so much easier to get data. The second problem we faced is the uncertainty in weather forecasts. The forecasts getting better and better these days, but they are not quite perfect. And weather is one of the main important factors for wildfire outbreaks. The third challenge I took is the complexity of factors influencing wildfires, which are not measurable or predictable, like human behavior. You can imagine people doing a bushfire. You cannot measure it or predict it. So this is the third challenge we faced. And the fourth challenge is about the multidimensional problem. So detecting or predicting wildfires is a multidimensional problem because we have time and space as a resolution, and the space is not two-dimensional, it's multidimensional, and we will see this in the next slide as well. So we go a little bit more into detail to our technical details. So we are using 20 years of history of more than 16 input features for our model, and we're using data from satellite images, maps, and sensors. We splitted our data into 4 categories. The first of all, as I mentioned before, is weather conditions like temperature, humidity, wind speed, wind direction. The second category is indicators of human behavior, as I mentioned also before, like population density, hiking trails, and so on. But as I mentioned, it's not so easy to get indicators of human behavior. And the third one is topological characteristics like slope and altitude. And fourth category is the label, so the historical fire information for South Africa. We have the location and the size when a fire occurred. Here on the left side, on the right side, sorry, you can see a small demo from our outbreak tool, where you can see the different likelihoods that a wildfire will occur. It's running in a loop for the next 7 days. So it's a prediction for the next 7 days. And coming to the algorithm we are using, so what are we doing with our data? The data is fed into this neural network. We are using a convolutional LSTM. So a convolutional neural network with different LSTM layers, and we are predicting the outbreak and the propagation for a 1 kilometer by 1 kilometer cell. And you can imagine here's an easy explanation of how the input layer of our model looks like. So everybody of you may know that a normal image has red, green, and blue layers, and for us we have different layers for each feature, which is going into the model. So I would like to show you with this use case that AI can have a huge impact to sustainability-related problems, and that it can make a change. And I brought a statistic. So the statistic says that by 2030, global greenhouse gas emissions can be reduced up to 5 to 10% through the implementation of AI methods. So I think this is motivation enough that everybody of you can do something in the field of sustainability and AI. And I brought just 3 other fields where you can implement use cases in the area of sustainability, for example, energy optimization or transport optimization or flood prediction. I will not go into detail, but I would like to motivate you to do your own impact in the field of sustainability. And thank you for listening, and together we can make a lasting impact.